All right, so we just did all this algebra and we determined I1 and I2 in the circuit. Let's go ahead and take those values over to the original slide, and then we can solve for the voltages that we need, okay? So we're going to go here. Let me go ahead and do some rearranging with all this stuff that I have now. I can take my two equations and move them and shrink them a little bit. Put them up here. And then I can take my two currents that I found and also shrink them a little bit and put them up here. All right. So let's go ahead and do all that. Now we can go ahead and solve for Vx, Vy, and Vz. Okay, so Vx, pretty easy to solve. We just use Ohm's law. We want to know the drop across this resistor. That's going to be 0 minus Vx. Oops, let's go back to blue. 0 minus Vx divided by 1K is equal to the current I1, which we found to be 1.667 milliamps, right? So I can say that negative Vx is equal to 1.667 milliamps times 1K, which tells me that Vx is negative 1.667 volts. Okay, so this guy is negative 1.667 volts. I'm going to go ahead and box that. I'm done with Vx. Vy, very simply, is literally just Vx plus 1 volt, because that's what the voltage source tells us. It tells us that the voltage on the plus side is 1 volt higher than the voltage on the minus side. So I can very quickly write that Vy is just negative 1.667 volts plus 1 volt, or Vy is negative 0.667 volts. So now I'm done with Vy. And Vz, we don't even need to analyze. We don't even need to use currents to analyze, but we could. We can either take Vz, right, the voltage drop across here, Vz minus Vy over 1K, set that equal to I2, which we found, or we can just assess right from the beginning that this is 0 volts. I know that I have a voltage source here, and my plus terminal has to be 3 volts higher than my minus terminal. And with that in mind, Vz has got to be negative 3 volts. All right, so I solved this circuit using mesh analysis, and we are done with mesh analysis for the time being. And in the next video, I am going to talk about probably one of the more dreaded topics in DC circuit analysis. I hated it when I learned it. It didn't make sense to me, but I am going to do my best to make it make sense to you, and that is Thevenin and Norton equivalence. And I think we're going to get it, because I think it's I don't think it's terrible now that I'm looking back at it, but I think that it's confusing to students, so we're going to try and tackle it together and make it make as much sense as possible, really drive home the motivation for why you would even want to use it, and let's talk about that in the next video.